Hello everyone, welcome to Explorer Hop. In today's worked example, we'll be looking at finding both the square roots of a complex number 11 plus 60i. So let's start. First, we'll assume that the square root of the complex number is x plus I y. So if I'll take the squares on the both sides, I would get z to be equal to x plus iy squared, which is equal to x squared plus 2ixy minus y squared. If I rearrange it a little bit, I would get 11 plus 60i, which is basically z, is equals to, now I'll write it in the form that I'll separate the real parts and I'll separate the imaginary part. So the real part would be x squared minus y squared, and the imaginary part would be then 2xy. Now, for both of these complex numbers to be equal, the real part and the complex part, the imaginary part should be equal to each other, which in this case is the real part of this number is x square minus y square. So x square minus y square should be equal to 11. And similarly, the imaginary part 2xy should be equal to 60. Now we have two equations with two unknown variables x and y, and we can easily solve these two equations to get the values of x and y. So the first thing I do is, from this equation 2xy is equals to 60, I would find that x is equals to 30 over y. Now the value of x that I found from here in terms of y, I would then substitute back into this equation to get x to get 30 over y squared minus y squared is equals to 11. Simplifying it a bit, I'd get 900 over y squared minus y squared is equals to 11, which in turn would be equal to y4 plus 11 y squared minus 900 equal to 0. Now, to find the value of y, we are basically supposed to solve this equation. So y4 plus 11y square minus 900 is equals to 0. If you notice, this equation is basically a quadratic equation with if of the form y square. So we can rearrange it just like a quadratic equation. We would write y4 plus 36y square minus 25y squared minus 900 is equals to 0. We wrote it in this form to basically factorize it and write it as two factors. So factorizing it, we would get y squared into y squared plus 36 minus 25 times y squared plus 36, which is equals to 0. And y squared minus 25 into y squared plus 36 is equals to 0. So we would have either y, like a normal quadratic equation, we would have y squared minus 25 is equals to 0, or y squared plus 36 is equals to 0. Now this is a very important step. We need to realize that y here y is basically a real number. Y cannot be a complex number. So the square of a real number is always a positive number. It cannot be negative. But in this case, if we say that y squared plus 36 is equals to 0, then we are saying that y squared is equals to minus 36, which would be a contradiction. So this means that this is not a solution of this equation, that it doesn't satisfy y. So we'll be taking this answer and we'll be using y squared is equals to 25. And solving it normally, we would get that y is equals to plus minus 5. So now we have two values of y. Because we have two values of y, we would automatically have two different values of x. So using each of the value, first we'll use y is equals to 5. So if we take y is equals to 5, then using this equation here, we can find x to be equal to 30 over 5, which is equals to 6. And similarly, if we take y to be equal to minus 5, then we would get x is equals to 30 over minus 5, which would give us minus 6. So now we have the y and we have the x. So we can write that the square root of z equals to 5, it would be equal to 6 plus 5i. And similarly, for the other value of y and the other pair of y and x, we would have or, because this can also be an answer. So we would have minus 6 minus 5i. Or a more concise way of writing it can be z under square root of z is equals to plus minus 6 plus 5i. And this is our final answer. And thank you for joining us. I'll see you all in the next lesson.